Greetings of the day. Welcome to another session of Grade 9 Mathematics. Dear students, today we shall be discussing about Chapter 4 Linear Equation in Two Variables. And this first part of the chapter, we shall be looking into the introduction of the chapter. Now, how many times have we come across this situation in the class wherein the teacher writes the title of the chapter, linear equation in two variables, and the next thing that we do is look at the clock above the whiteboard and figure out how much time is left for the period to get over, isn't it? Now, we all like to solve these kind of questions that we often get on different social media platforms. Isn't it? An apple plus a strawberry is equal to 5. Two apples plus three bananas is equal to 8, and so on, as you could see on the screen. And then we have it, we'll be asked to figure out what will the value of apples, strawberries, and bananas over here. Yes, it is very important for us to understand why are we learning linear equation in two variables, the concept itself, because it enables us to translate the verbal expressions into mathematical symbols, as you could see in this particular picture. It helps us to solve real world problems using linear equations. These are the two major objectives that why are we learning the concept of linear equation in two variables. Let me give you a few examples. Now, these are the common phrases that we come across in our mathematical problems. Something like 6 more than a number. So how can I write it using an operation? So if the number is x, which is an unknown number, 6 more than a number can be written as 6 plus x. Say if the statement was a number increased by 8, so I can write, okay, there is a number, a number, which is x, and it is increased by 8. So I can write it as x plus 8. 5 added to a number could be written as 5 plus x. The sum of a number and 17. So the sum of what? A number and 17. So if x is an unknown number, yes, so x plus 17 could be the mathematical way of writing the phrase the sum of a number and 17. Now let us come across a few phrases that represent subtraction. 18 decreased by a number. 18 decreased by a number can be written as 18 minus x, because 18 is been decreased by a number and we don't know that number. So that number can be taken as x, and you can write the entire phrase as 18 minus x. Let us take one more example. 6.5 less than a number. I repeat, 6.5 less than a number. So you have a number, yes, which you are never of right now. Let us take it as x, and 6.5 less than that. So the number would be x minus 6.5. Similarly, as you can see on the screen, we can go with two more phrases, something like this. 3 subtracted from a number, which can be written as x minus 3. Or say if the phrase is the difference between a number and 5, you can represent it as x minus 5. So these are the common phrases that we often come across in the problems you will find it in your textbook, yeah, regarding linear equation in two variables. And this is something that you should learn to solve the problems, how to convert these phrases into mathematical equations. Now, as I did say, the two major objectives of learning linear equation is to solve uh, the real life problems, as well as to learn to convert the verbal statements into mathematical equations. Now, uh, let me take the first example, which says translating verbal statements into symbols. That is, you could see on the screen there are 5 statements which I have put it forward for you, wherein we're supposed to translate each of these verbal statements into symbols. 14 times a number. Can anyone tell me what would be 14 times a number? Yes, it will be x into 14. Let us look into the next statement and see whether we can translate this verbal statement into symbols. A number divided by 7. I repeat, a number divided by 7. So let's take the unknown number is x, okay, and if it's divided by 7, how would we represent it as x upon 7? And likewise, I put three more statements which you can go through and try to translate these statements into mathematical formulas using symbols. Now, the second example of linear equations that we do come across is wherein we have been asked to solve a basic translation problem. For example, you must have come across such questions in your previous grades, wherein the question could be, if 8 times a number plus 3 is 27, find the number, isn't it? Yes, we all have come across such questions, and I believe I've found it over the years that this is where the student finds linear equation a little of difficult. Yes. So what are you supposed to do? You have to break down this statement into small phrases. If 8 times a number, so how do you represent 8 times a number? Yes, that is 8 into x, which is 8x. 8 times a number plus 3, that means 8x plus 3 is equal to 27. You have got your verbal statement converted into an equation, a mathematical equation. Let me put the third example wherein you may come across a mathematical problem involving contract negotiations. So the example that you can see on the screen, say you have got two basketball teams who are interested in signing a free agent player. Now an inside source informs the general manager of one team that the other has made an offer and the player's agent said, double that and add an extra million per year and you are in our league. So here the offer to the player has been in a phrase which can be converted into mathematical equations. So what is the phrase being used over here? Double that and add an extra million per year and you are in a league. Now, according to a published report, the player is seeking a contract of $18 million per year. So what was the rival team's offer? Isn't it? An interesting one? Indeed it is. Now, let me take you to another example wherein linear equation can be applied. Say an application to home improvement. Let me give an example. Pat and Ron are planning to build a deck off the back of their house and they buy some plans from the internet. The plans can be customized to the required deck height, which in this case will be 92 inches. Now they go for support posts of two different heights. The taller ones are 8 inches longer than the shorter ones. And the plans say that the sum of the length should be the height of the deck. Yes. How long should the support post be cut? So here again you can put the concept of linear equations and get to the answer of how long should the support post be cut if the taller one has to be 8 inches longer than the shorter one. So break the question into small phrases and then convert it into mathematical equations. Another example where linear equation can be applied is an application involving, say, money. For example, we must have come across this question, say in grade 7, grade 8, wherein after a busy homecoming weekend, the tip jar at an off-campus bar is stuffed full of quarters and dollar bills. It turns out that there are 3 times as many quarters as dollar bills, and the jar contains a total of $140. How many quarters and how many dollar bills are there? Isn't it another application, another question where you can actually apply linear equation? Yes. Now, let me get to you a one very interesting and example wherein again you can use linear equation. We do use it, but then we don't realize that we have actually used linear equation in this situation. Say a batsman has scored some singles, some fours, and some sixes in a cricket match. The number of singles made by a batsman is three times the number of fours scored by the same batsman. I repeat, the statement is the number of singles made by a batsman is three times the number of fours scored by the same batsman. The batsman also scored a few sixes. Now, the batsman scored a total of 84 runs. What you're supposed to do is form a linear equation based on the batsman's total score in terms of the number of singles and sixes scored by the batsman. So you may take that the number of fours be x. So how many singles did the batsman take? Three times the number of fours, that is 3x, isn't it? And the remaining sixes added, what you get is the total score of the batsman, which is 84 runs. You can use the equation to find the number of singles or say the number of fours as well as the number of sixes scored by the batsman. We are coming to the end of this video. Hope you have understood the different applications or real life problems wherein you can use linear equation into variables to get to the solution of those problems. On this note, we are ending up this particular first part of the chapter, Introduction to Linear Equation to Variables. Take care of yourself until we meet next time with another session. Thank you.